In last class, we have discussed problems on force voltage analogy, and also we have discussed regarding force current analogy. We have discussed three problems on that, and also we have discussed a theory about that. So watch before videos what I have explained with introduction to control system, and also related to mechanical system, how we can translate to rotational, and also the force voltage analogy. Okay, translational and rotational, and also force voltage and also force current analogy. For mechanical system shown in figure, obtain force voltage analogous electrical network. They have given this network. So first observe how many displacements are there. X1, X2. Okay. So two displacements are there. So how many equations you will write? Two equations you should write. So first for X1. So for X1, how many connections are there? M1 is connected, K3 is connected, K1 is related, and B2 and also F and B1, right? K1 is between X2 and X1, B2 also between X2 and X1. So what we can write equation force is equal to, because force is also related to X1 only here. D square x1 divided by dt square plus b1 dx1 divided by dt plus k3 into x1 plus k1. K1 is connected for both. So what you should write? X1 minus x2 plus b2 d of x1 minus x2 divided by dt. This is the first equation we have written for first displacement. When you write the equation for second displacement, there is no force. Okay. So 0 is equal to K1 x2 minus x1, x2 minus x1 plus b2 d of x2 minus, this should come x2 minus x1, okay, x2 minus x1 divided by dt plus m2 d square x2 divided by dt square plus k2 into x2 plus b3 into dx2 divided by dt. B3 and K2 is connected separately for the X2 only. That's why they have written K2 into X2 and B3 into D of X2 divided by D2, dt. Okay. So for this is a mechanical system what we have written here. So X1, X2. First we need to draw the X1, X2. So for X1, how many connections are there? And for X2, how many connections are there? And between X1 and X2, what are the elements connected? Okay. First, if you draw this mechanical system so that you can write the easily equations. Okay. Next, we need to convert this mechanical system to force voltage analogy. So that is what they have asked in the question. Okay. For a mechanical system shown in figure, obtain force voltage analogous electrical network. So we need to draw, for this system, we need to draw the electrical network. Force voltage analogy with L, and B is replaced by R, and K is replaced by 1 by C, and D of X divided by dt is replaced by I. If you differentiate this one, you'll get d square x divided by dt square di by dt. Okay, if you integrate this one, you'll get x integration of I into dt. So you remember this force voltage analogy. Okay. So now we will apply this for equation 1. M is replaced by what? L. Okay. So M is replaced by what? L. So M1 is replaced by L. F is replaced by V. Okay. Force voltage analogy. In heading only it is a force voltage analogy. M is replaced by L and V is force is replaced by V. V is equal to L1 di by dt plus R1 I1 plus 1 by C3 into integration of I1 into dt plus 1 by C1 I1 minus I2 dt plus R2 into I1 minus I2. So here B2 is replaced by what? B2 is replaced by R2. Okay. and k is replaced by 1 by c. Okay. So just to replace the terms instead of m, b, k. Okay. After replacing, you'll get the two equations. Okay. By seeing that two equations, you need to draw the electrical network. So two equations means two loop. This is the loop 1. Okay. And this is the loop 2. Or we can say I1, I2. This is I1 and this is I2. Okay. So I1 minus I2, where you got? So for capacitance and for R2, that is for C1 and R2. So you should write here. Okay. Left all, you should write. So for second equation, C2 is here into I2. So you need to write here. Okay. And L2. L2 into di2 divided by dt. So L2 you need to consider. And R3. Okay. So according when you take the loop equation, you should get this equation. Okay, like that you need to draw. First, you analyze the where you will get the middle one. Okay, between it should be for both the loops. Okay, so I1 minus I2 like that, or I2 minus I1 you'll get for only C1 and R2. So first you should write that one. Later, left terms you should write here. Okay. It's the fifth problem. Next problem, that is draw the force voltage analogy and current analogous circuit for the mechanical system shown in figure with the necessary equations. They have given like this. First, we write this one. We draw this one. Okay. So, how many displacement are there? X1, X3, and X2. Okay. So between x1 and between x2 and x1, what are the element is connected? K1 is connected. Between x1 and x3, B3 is connected. Between x3 and x2, K3 is connected. Okay. For x1, M1, F, K1, and B1. So for x1, how many connections are? B3. Okay. B3 also is there here. B3 is between again x1 and x3. That you should remember. First, you make three dots. Okay. This is x1, this is x2, and this is x3. Okay. Between x1, for x1, how many connections are there? One is mass, one is K1, one is B1. Okay. One is B1. And here B3 is connected between x1 and x3. So you should take here B3 is between x1 and x3. Okay. Next, for between x1 and x2, what are the connection is there between x1 and x2? K1 is there. Okay. So instead of writing here, what you should here should write. Okay. K1 you should write here because it is between x1 and x2. How would we are saying between x1 and x2? You can say between m1 and m2 because m2 is connected here already x2, so it is related. Okay, so we can say that k1 is related for m1 and also for m2. M2 is connected for what? Again x2, so it is interlinked. So k1 you should consider, and for x2, how many connections are there? K3 is connected, B2 is connected, M2 is connected. So K3 is between X2 and X3. So you should write here K3 between X2 and X3. And M2. Okay. One is M2 and one is B2. M2, B2, and next K2. So same here we have done. Okay. Same. This is K2. This is okay. Now we should, how many equations you will get? So three equations you will get. Now what you should write for x1? F of t is equal to force is equal to always. Okay. F of t is equal to m1 d square x1 divided by dt square, and this is what, this is v1 into dx1 divided by dt, right? F of t equals to m1 d square x1 divided by dt square plus v1 dx1 divided by dt plus k1 into x1 minus x2 plus, so what we'll get again, b3 dx1 dx1 minus dx3 divided by dt. This is what you'll get the equation 1. That is what here I have written, f of t is equal to m1 d square x1 divided by dt square plus v1 dx1 by dt plus k1 x1 minus x2 plus v3 dx1 minus x3 divided by dt. Next is for second x2. What are the elements connected? K1. So what you can write here? K1 x2 minus x1 and plus, yeah, 0 is equal to, because there is no force connected for x2. So 0 is equal to m2 d square x square and d square x2 divided by dt square plus k2 into x2 plus into dx2 divided by dt plus k1 into x2 minus x1 plus k3 into x2 minus x3. This is what you will get, k1 x2 minus x1 plus m2 d square x2 divided by dt square plus b2 dx2 divided by dt plus k2 into x2 plus k3 into x2 minus x3. Next equation, what you can write by seeing the diagram, only two elements is connected, b3 and k3. k3 x3 minus x2 plus b3 dx3 minus x1 divided by dt. So now we have written the equations. Okay. Next, we need to convert what? Force voltage analogy. M is replaced by L, B is replaced by R, and K is replaced by 1 by C, and X is replaced by what? Q or next dx by dt is replaced by I, and if you differentiate this one, you'll get this one. If you integrate this one, you'll get x integration, and that is integration of I. So replace the terms, three equations you need to replace. Then after replacing, similar, what we have drawn the mechanical system, similar you need to draw. Okay, there are three loops. Okay, there are three loops. So this is I1, this is I2, and this is I3. Okay. So what are the elements related to I3? C3 and R3. So C3 and R3. Okay. That too, one thing you need to observe is C3 is connected for both the loops I3 and I2. So you should write here C3. And R3 is for two loops I3 and I1. So you should write here. And left elements you should write here. Okay. And C1 is connected for both the loops I2 and I1. You should write in the middle. Okay. Next, force current analogy. Replace the terms M instead of C, and B is replaced by 1 by R, K is replaced by 1 by L, and X is 5, and dx by dt is V, and X, if you integrate this one, you'll get integration of V into dt. If you differentiate this one, you'll get dV by dt. So after replacing these terms, so similar what you have done, okay, mechanical system, replace there itself. Okay, instead of what we have done, L1. Instead of D3, what we have written R3. Instead of K3, L3. Instead of M, we have written C, like that. Okay, replace they itself for only force current analogy. If you draw the mechanical system, there only you replace the terms for force current analogy. You cannot replace the terms in force voltage. You need to draw the loop equations. You need to draw the circuit, total complete closed loop circuit, like that. Okay. In next class, we shall discuss with the other problems.